that can fail will fail. So, somewhat risky title for a talk, especially one that is made up of about 50% live demo, but it's all good. The purpose of the live demo is that things do fail and we learn about how to fix them. So, some of you may recognize this as Murphy's Law. It's a kind of common law, something that is fairly widely known, but today we're going to be looking at relating this to AWS, so Amazon Web Services. Not just relatable to AWS, other clouds also apply in this case. But yeah, let's crack on. So, my day job is a solutions architect for an AWS partner, so this kind of stuff is my bread and butter. If you wanted to connect and chat, etc. afterwards, then LinkedIn, website, I do some blog posts about AWS as well. These talks, public contributions, that sort of thing, is really what I love about the community. Love being able to share knowledge, learn from people, meet new people, new professionals, people learning AWS, all of this good stuff. I run the AWS user group in Ipswich, so if anybody fancies a quite short journey down to Ipswich, if you really want to, then that runs 4 or 5 times a year. The next one is in April, hopefully. So that's just got started. But for our talk today, so business success is, it's really blinding me there. Business success is often intrinsically linked to the resiliency and the reliability of software systems and applications. So downtime in these systems will lead to things like lost sales, potential fines, if you've got SLAs with customers, refunds, all those sorts of things. I'm sure we've all been in situations like this where bosses, customers shouting at us because something's gone down, but it's not always necessarily our fault. In today's world, we rely on third-party systems, whether good or bad reasons, and some things aren't always in our control. So what I want to do today is I want to tell you about a little bit of a story. So we're going to try and have some fun, try and inject some life into a room straight after lunch. And this story is going to take us on a journey from on-premises to the cloud, learning about resiliency and reliability along the way. So keeping in with the NorDev theme of crabs, today's story is a crustaceans migration to the cloud. I will apologize in advance if any of the images aren't entirely accurate. Generative AI has not quite grasped the concept of claws yet, but we'll give it a go. So this is our main character. So our main character, Clara Codeclaw, she's a software developer and she works for a local website design agency. This website design agency, they design websites, they build websites, and they also host websites for their customers. One of the websites that this agency is responsible for is a particularly high-profile website. It's a music festival that runs every year, and this festival is called the Summer Crabtacular. All of this is hosted on premises. So they host all the websites on one server. They lease this server within a much larger data center. But ultimately, they can't go and touch it. They can't go and do anything with it. They just have access to it, kind of much like you would with the cloud, I suppose. So there's some parallels. All is well. Everything is normally fine. Until one day, hardware failure. So there's been a power surge. The rack of servers has had a power surge, and there is now damaged hardware. The agency have no SLA, no support contract with this data center. And as a result, there's no real time frame, no promise as to when this is going to get fixed. So for them, there's not really much they can do but sit and wait. So as we would expect here, I have no idea why teeth have turned up here. I tried so many times and could not get them to go anywhere. Customers not happy, it's what you'd expect. Some are crabtacular, they've been building up press, digital marketing, print advertising, everything to launch their website and launch their tickets, more importantly, this weekend. But the website's now down. What do? Obviously they're going to shout at Clara's agency. Doesn't have to be the way. And we're going to learn about why not and how. So, what next? This magical thing called the cloud. So, let's explore this a little bit more. So, today we're going to look at AWS. AWS is my area of expertise. There is a talk, I think, downstairs after this one about Azure, and a lot of that actually will probably relate into what this is. So if Azure is your flavor of choice, then definitely check that one out. If you choose to use Google or Oracle, then well, sorry, and please come and speak to me afterwards, and I will persuade you otherwise. So, just before I kind of launch into the AWS stuff, just as a kind of show of hands, who would say they are kind of new to AWS, whether it's very early stage or heard of it but has never done anything with it at all? Okay, a good proportion. And then kind of middle level, so using it maybe day to day. Okay, and like, I am the best. Good, no one's ever the best. Brilliant. So, AWS have this enormous global infrastructure. AWS itself, I think, launched back in 2006 publicly, and was used internally inside Amazon for a few years before that. And this reaches kind of all corners of the globe. So AWS have 33 regions, to be exact. Regions are kind of located around a particular geographic area, and 4 more are planned and in the works. So think of regions like London is one, Dublin, Ohio, Sydney, Cape Town, North Virginia. They're kind of big enough, but not as big as, say, Europe or USA. A region is a collection of data centers. So that's kind of the key thing to keep in mind here. It's not just one data center, it is a number. You'd often choose a region based on a number of things. So this may be latency, for example. So it may be that all of your users are based in the US, and as a result, you want to host your data as close to them as possible to keep the time it takes that data to be transferred as low as you can. The other reason could be things like data residency or data sovereignty requirements. So if you are hosting personal data about people from a particular continent, then there may be regulations or laws that say you must host this data in the US or in Europe or in the UK, for example. I've written a blog post quite recently about building things at kind of global scale on AWS. I will make the slides available afterwards, don't worry too much about photos and whatnot. I'll find a way to post them somewhere. Cool. So let's kind of dive into one particular region, which is London. So London is our closest region to Norwich. Realistically, I probably can't see there being another England-based region. You have got Dublin in Ireland, but Northern Ireland maybe, but yeah, England-based London is the only one currently. So in AWS terms, London is referred to as EU West 2. So this kind of naming convention is made up of 3 different components there. The EU being the kind of signifier for the not always continent, but the wider geographic area. So you have things like EU for Europe, US for United States, AF for Africa, AP for Asia Pacific, ME for Middle East, and others. West is what it says on the tin, just on a compass where it is within that overall bound, and then the two being whether it's first, second, third, fourth in the EU West area. So, as we said, regions are made up of a number of data centres. So, these data centres are referred to as availability zones. So, availability zones are distinct data centres. AWS don't publish exact locations of these for security reasons, primarily, but they do give us some parameters around how they choose locations, and I think people have tried in the past to work out where they are, and I mean, you can't miss them really. So if you happen to be driving by one, then you'd be able to guess. So just for argument's sake, and these definitely are not the actual locations, I have just picked 3 random points in London, and that's not me being sneaky, it is genuinely random points. Let's say we have 3 locations. So in London you have 3 availability zones, and the parameters that AWS publish around how they determine the location of an availability zone is twofold. So availability zones are always kind of connected to each other. So, for example, if you had an application that was deployed across availability zone A and B, and A fails, then fine. If you have an application across A, B, and C, and B and A fail, it's still fine, it's still running, still accessible. Between availability zones, there's this parameter of geographical distance. So they are always less than 60 miles. So could be 59, could be probably 10 upwards, I would say. And the idea behind this is it tries to prevent correlated failures of data centers. The idea being, if there was a flood, a fire, natural disaster, man-made disaster, anything like that, 60 miles or up to 60 miles should be enough to stop it. Not always, but in most cases, yes. Overall goal is data center A goes down and data center B goes down. They shouldn't be for the same reason. Another one is latency. So because when you are deploying your applications, or AWS are deploying their services across multiple availability zones, they're all in communication with each other, there has to be less than 10 milliseconds latency. So those 2 key stats there, as in less than 60 miles and less than 10 milliseconds. There's a couple of things, I guess, to consider with this, in that I've had some customers before where they've said, my data needs to be resilient, needs to be multiple copies of my data, but it has to be 300 miles, for example, away from each other. And that's quite tricky. In London, obviously, you can't do it. I don't know how far Dublin is from London. But yeah, as in one region, you can't do it. So you have to start looking at multiple regions. And the other one is latency. If you have an application that is particularly latency sensitive between components of the application. So let's say you've got 2 servers that are talking to each other, doing very different things, but the communication between them is really important. It might be that 10 milliseconds or 9 milliseconds is too much latency, and hosting them in multiple availability zones is a problem. However, hosting them in the same availability zone, you can get that much lower. And if you wanted to look at having things more resilient or more redundant, you can just have copies in other availability zones. And we'll come on to that. So this is where we kind of come back to our back to our story a little bit. So how can we help Clara and her agency? So the journey we're going to go on here is kind of 3 steps. One is to understand how things are right now. So what is the current state? And have a little bit of think about how and what that could map to in AWS. Followed by establishing the real foundations. So I always like to pitch this as you'd never build a house on weak foundations. You'd never think about building a house until you've thought about building the right foundations. So don't do the same with cloud infrastructure, because at some point it will come back to bite you. And the final bit being, let's move the thing and migrate it, modernize it. Not always a linear process. Sometimes it's 2 or 3 phases. Sometimes it's a long iterative process. It might be you have a requirement to get a service out of your data center by a certain date, and there isn't time to modernize it. So you pick it up, you move it, you lift and shift it, and then you start thinking about modernizing it incrementally as it goes along. So thinking about how things currently look. So in this on-premises data center, it's a really simple architecture. We have the application itself and the database that talk to each other. No kind of complexities. It's a Laravel node, kind of whatever you want to relate to here. A fairly standard web application. So we're going to have a little think about, if I stand in the middle, then that really isn't going to help, is it? I will stand here. There are 3 AWS services that we are going to have a think about, and we're also going to see 2 of them in action as well. So EC2 is essentially AWS virtual machines. So if you are picking something up from one place and moving it into AWS, the chances are EC2 instances are the way you're going to go. We're going to look at load balancing as well. That comes with a number of benefits, not just for load balancing, but also there's some nice bits around resiliency and redundancy and replacing damaged instances or damaged hardware as well. And we aren't going to look at the database service today, the relational database service, but if you're moving a database into AWS, then Amazon RDS is the managed solution for databases. So in terms of the kind of the foundations that my bottle is definitely blocking that. The foundations we want to talk about. There are 3 different foundations here. So networking being one. Thinking about, is there things still in your data center that will need to talk to applications you're moving? Maybe it's some kind of hybrid networking. AWS have lots of options there, whether it's using things like VPNs, or if you have particularly sensitive data or have very high throughput requirements, for example, then you can get AWS to literally lay cables and link your data center to their data center, which is pretty cool, but also fairly expensive. Security being another one. Security encompassing encryption, identity, network security, everything. It's just treat it as a day 0 job. Don't start building until you know how developers are going to use AWS, because what always happens, and I say always, 99% of the time, people will start off and say, I'm going to give everyone admin access because it's always the easiest thing to do. And then 10 years down the line, it's like, everyone now has admin access, which isn't a great solution. And the final one isn't always one you see described as a kind of foundational thing, but I think it's probably arguably one of the most important. So FinOps, so short for financial operations. So if we think about an on-premises data center, the financial side around it is fairly straightforward. It's you're leasing a server from company X, or if you've got your own data center, you are buying some physical hardware. I expect this to last for 10 years, and it amortizes at this rate per year. So that's kind of generally quite easy for finance teams to understand, because they see an invoice that says £10,000 on a server, one-off payment, done. Cloud gets a little bit interesting because it is truly pay-as-you-go. So at the moment, my demo account on AWS is running my live demo, so it's costing money. This evening, when I tear all of that down, it stops costing money, which is great. The thing I think that often gets forgotten with cloud is, I've forgotten. I think that the link that people don't make is it's very easy to build on the cloud. People go into the console, they say, I want to create this, great, I've got a system. But as a developer, you don't ever see the cost of that. The person whose credit card is on the account does. But it's trying to build this culture of making every single engineering decision in the cloud a buying decision. When you are looking at pull requests and someone is saying, okay, I want to double the size of this instance, ask the question why. Like, is it because it genuinely needs more resource because there's more customers? Or is it because someone's written some bad code when actually it's not a hardware problem, it's a traditional software engineering problem where people need to optimize the code rather than just throw more money at it. So, final stage. Cool. This is where we're going to get hands-on, so, or claws on. I'm trying to do some humor here, it's not really working. It's still not as bad as, I think the first year that I gave a talk here, we were talking about data lakes, and there's this concept in data lakes called a data swamp, and me thinking, let's have some fun, I was like, Swamp Shrek, straight away in my head. So picture Shrek goes up, deadpan, whole room. It's like, yeah, this is gonna be fun. Cool, so let's move this chair so I can sit down and not lean over and get hunchback for 20 minutes, or less than that even. I have, what, 15 minutes, don't I? Yeah, okay. So, is that Zoom okay for everyone at the back particularly? All good? Lovely. So, this is a real AWS account. There's no kind of trickery or anything here. So we're going to look at this sort of latter stage of the life cycle. So things have been moved, but for demonstration purposes, I've actually built things twice. So there's 2 web servers running here, which if you really wanted to, you can go on your phone and visit them. They are live. Although thinking about the title, maybe that isn't a good idea. One of them is hosted in a single availability zone, kind of specifically EU West 2A, and one is hosted in 2, which is EU West 2A and 2B. So 2 exact same copies of an EC2 instance, just running a Nginx web server. The only difference is one says multi-AZ and one says single AZ. And we can see these 3 instances here that are all running. What I've also done is there's a service in AWS called the fault injection service, and the fault injection service is basically there to allow you to do chaos engineering. So deliberately introducing failures to test how well your applications and your infrastructures respond to the kind of failures that sometimes do happen. AWS regions are generally pretty resilient in terms of you don't see them go down very often. Availability zones, they are there, I guess, so you can design your application so that AWS aren't necessarily always committing to 100% availability on them. So in this particular experiment we're going to run, we're going to do 3 different things. So we're going to disrupt connectivity in 2 subnets of our network. One is the subnet where our EC2 instances in EU West 2A are hosted, and one is the public subnet, which is where one of the nodes of our load balancer is hosted. So we're kind of almost testing AWS services as well as the ones we've built here. And the final one is the way this is built is using a feature called auto-scaling groups. And with auto-scaling groups, what will happen is I've given it a desired capacity. So I've said I want to always have two EC2 instances running in this group. In an ideal world, these are going to be balanced across multiple availability zones. And we've said your kind of scope is 2A and 2B. But if you can't do it in 2 availability zones because, say, the health check fails on one of them, then put 2 in a different one, but then try and rebalance them continuously so that when availability zone A comes back up, you can then take all the dependencies out of one zone. So what we're doing here is we're going to force the auto-scaling group service to not launch anything in zone A. We're going to inject an error so that when it tries to, it's going to say it has insufficient capacity. So this service obviously gives you the warnings of, are you really aware you're about to break things? Which in this case we are. So I think this charges you about 10 cents a minute, but it's not meant to be run very often. You're only really meant to run it, perhaps like do it as a scheduled thing, treat it as an MOT for your infrastructure, but more regular. So maybe run it once a week, once a month. The cost of running it is significantly cheaper than your application having downtime and losing sales, or having to pay a fine, or giving a customer some money back because you promised them 100% availability because your salespeople are over-enthusiastic. Not speaking from experience. So we've injected faults here in 2A, that availability zone. So we know this one here, which is our single availability zone instance, should now, I don't quite know if you can see that. Let me move this down. There we go. So the load balancer has tried to reach this instance. It can't, because what the fault injection service is essentially doing is saying for that particular subnet, don't allow traffic in and don't allow traffic out. And that's the simulation of an availability zone failing. Then what we can do is we can look at this, and we will see, if we look at the load balancer and our multi-availability zone one, we can now see that one of them has failed its health check. So the health check is basically used to determine, can I route traffic to that particular instance? In this case, R1 in EU West 2A, it can't. It's unhealthy, so traffic won't be routed there. Then we can see our status has just changed, so it's now draining any connections from that. So what we might find is if we refresh this, it's still draining the connections. But as this has now triggered the unhealthy instance, and it started to deregister that. We will see in a second, if we look at this one, that we've got one unhealthy one here, and we've actually got 2 instances launching or have launched in EE West 2B. And if we look at the activity here, we can see in the log we have got the health check failed down here, so identified that it needs to be replaced, and then it's increasing capacity, and now what it's trying to do is it's trying to rebalance it, because we've got 2 in one availability zone, but it wants to have 1 in each. So it's going to keep trying and trying and trying, basically until our experiment times out, which I think is half an hour. But we'll stop it before then. So what we can see is this is all worked now. So everything has failed over. We've got our 2 healthy ones. Our multi-availability zone version is still up, and our single availability zone 1 is still going to carry on failing. So what we can do is we can stop this, and it will do the inverse and return back to normal. I don't have time, 20 past, cool. The nice thing you have with auto-scaling groups is they haven't actually got to be multiples. So people often have this association of, to be more resilient, I have to spend more money. And that's only really the case if you need super fast failover. So if you don't need super fast failover, then what you can do with auto-scaling groups is you can actually say, my desired capacity is 1. Here's 3 availability zones you can launch in. And what it will do for you is when one availability zone fails, it will launch that instance in another one for you. So you're, at any one time, you're only paying for 1 instance. You're not paying for 2. The downside of that is there is a longer time because you haven't always got one core one running. I am, I think, running fairly close to time, and I want to leave a little bit of time for questions. So just a few points to round up. Always use more than 1, even if it's just, as I said, so even if it's not having things deployed in more than 1, just have things configured so that if something does go down, it's easy to fail over to something else. The process is in place. Even if it's not a 10-second, 30-second thing, maybe 5 minutes is fine, but it's better to have that in from the start. Always plan for the worst. As great as I generally think AWS are, they are by no means infallible. Infrastructure does fail, infrastructure does go wrong. It is what it is. We have to build to go around it. But think about the trade-offs. Think about money. Think about customer expectations. All of these things that don't always mean a little kind of hobby website needs to be deployed in 4 different regions around the world, because realistically it doesn't. But if you're a bank, then yeah, you probably do want to have a think about doing that. Deliberately break things. So look at chaos engineering. Do it in non-production, please. I don't want to be held responsible for bringing someone's production environment down, but spin up a mirror of your production environment, even if it's just for a couple of hours, break things, tear it down again. Look at infrastructure as code to help you do that. So things like Terraform, CloudFormation, the AWS CDK, all of these things to help this process. If you want to talk more about this stuff, please just come find me online, in person, whatever. Always happy to chat about this. Come to Ipswich if you really, really want to. I'm from Norwich, so don't shoot. Otherwise, thank you for listening, and